So we're just going to do a couple of examples with substitution and addition solving linear equations. So the first problem that I have is 5x plus 0.3y is equal to 1.4 and 0.2x minus 0.1y is equal to 0.28. Now if you'll notice on this particular problem, I do not have a leading coefficient of just a 1. There's going to be still a couple of different ways I can use substitution or I can use addition. If I don't have one that's immediately a leading coefficient of 1, I'm going to do addition. It's going to be much easier. So what I can do is I can still multiply the first equation by just a 1, because notice my y's are already opposite signs. And then I'm going to multiply my second equation by a 3, because 3 times 0.1 gives me that 0.3y. And so my first equation is still going to be 5x plus 0.3y is equal to 1.4. The second equation is now going to become 0.6x minus 0.3y equal to 0.84. So now notice that I can eliminate the y's by adding these two equations together. And so I'm going to add these two equations together, get rid of my y's, leaving me with a 5.6x is equal to a 2.24. I will divide both sides by a 5.6, divide by 5.6, and that's going to give me that x is equal to 0.4. Now again, I just have x, I've got to solve for x and y, so I'm going to plug this into the one of these original equations. It doesn't matter which one. I'll be honest, I tend to always choose the first one. So 5x plus 0.3y equal to 1.4. So I'm going to plug in 5 times that 0.4 plus my 0.3y is equal to 1.4. So 5 times 0.4 gives me a 2. Plus 0.3y is equal to 1.4. I'm going to subtract my 2 from both sides, and that's going to give me 0.3y is equal to a negative 0.6. I still need to get y by itself, so I'm going to divide both sides by 0.3, which will give me that y is equal to a negative 2. So therefore, 0.4 comma negative 2 is a solution for this set of equations. Let's try another one. This one, notice it has a fraction in it, so we're going to leave answers in fraction form if we need to. And so whenever I'm working this, I'm going to look, notice I already have y equals. So on this particular one, I'm going to use substitution because I already have one of my variables solved for y. So I'm going to take this and plug it into the y here. Okay? And so I'm going to end up with 2x plus 4. And then in place of my y, I'm going to put 5x minus 7/4 equals my 4. And I'm going to solve for x. So I've got to distribute the 4 to both items. So 4 times 5 gives me 20x. 4 times a negative 7/4 actually gets rid of my fraction for now and gives me a negative 7. Remember to bring down your 2x. I'm going to combine my x's to give me 22x minus 7 is equal to 4. And now I'm going to solve for my x. I'll add 7 to both sides. And I'll get 22x is equal to 11. Here, make sure that you always divide by the number attached to the variable, okay? It's not divide by the smaller number, it's divide by the number that's attached to the variable because you want to get this x by itself. So you want these to be able to cancel out. And so here is where, because we started with fractions, I'm going to end with a fraction of 1/2. Okay? Now, fortunately, I'm not finished because I just have x. So now I'm going to plug this x into the second equation. I could plug it into the first, but why? I already have this solved for y. So I'm going to use that y is equal to 5 times a 1/2 minus 7/4. So where I multiply the 5 times the 1/2, I get 5/2 minus 7/4, because remember we put it over 1 and we multiply straight across. Now I have two fractions. I need to find a common denominator, which in this case is going to be 4. So I'm going to multiply, oh, not by 4. I'm going to multiply this one by a 2 to get my 4, and multiply the numerator by a 2 to get my 4. So I get y is equal to 10/4 minus 7/4. Wherever I subtract fractions, remember I just subtract the numerators. 10 minus 7, so y is equal to 3/4. So I have 1/2, 3/4 is a solution. Okay? Again, I left them as fractions because I began with a fraction. So you kind of want to leave it wherever you have it, okay? So try a couple and then we will look at some more.